Morning class, we're going to go 3.3 parallel lines and triangle sum theorem. So, we're going to look at it. Triangles, the sum of the triangles, all the angles in the triangle will add up to 180 degrees. So we're going to go ahead and go through it. So, if we have a triangle here, we have angle 1, we want to find out what it is. We know this is 65, this is 35. All those angles will add up to 180 degrees, so we say that 35 plus 65 plus angle 1 equals 180. Add 35 and 65 together, which would give you 100 degrees. Subtract 100 degrees, and we can say angle 1 is equal to 80 degrees. Next example, we have a triangle, M and P is a right triangle. That means right has a 90 degree. M is a right angle, so angle M. Angle N is 58. Find angle P. So we could draw that up. Draw a right triangle, 90 degree angle. Label angle N 58 degrees. And we'd say 58 plus 90 plus P should equal 180. Combine 58 and 90 gives you 148, and then subtract it. 148 minus 80, 180 is 32 degrees. So whether it's in picture or in word, triangles have to have 180 degrees. So now we go through here. Looks like a lot. Well, let's start with the X. We know this angle, this angle, and this angle has to add up to 180 degrees. And now we can solve. Can add these two together. 39 plus 65. Okay? And then subtract that, which would give you 76. Solve for Y. Well, look at X and Y. What do X and Y add up to? They form a straight line. So you know X plus Y would equal 180 degrees. Or 76 plus Y equals 180. Subtract it, so Y would equal 104. Last one. So if you know this, this angle right here is 104. This angle is 21. Then we'd add that to Z, and we should get 180 degrees. Combine, which gives you 125 minus 180. So your Z is equal to 55. So now we want to classify. Equal angular means all the angles are equal. Equilateral, all the sides are equal. Acute means all the angles are less than 90 degrees. Right means we have one angle that is equal, or one angle that's 90 degrees. And then we have obtuse, means one angle is greater than 90. So you can't have an obtuse right triangle. So isosceles means we have two sides that are congruent. Scaling means no sides are equal. So make sure you write those down. So once again, you have equiangular, equilateral, right, obtuse, acute. And then you have scaling, isosceles. So we want to classify it. We have these two congruent markings right here saying these two sides are equal. So if two sides are equal, then we know that that would be isosceles. Now, do any of these angles look like they're right or that they're greater than 90? No? So we call that scaling, an acute isosceles triangle. Because acute stands for all the angles are less than 90, and isosceles means we have two congruent sides. Come to this one. If you look at it here, we have a 90 degree angle, so that speaks of it being a right triangle. Now, do any of these sides, any of them seem equal? No, so we call that side, so it would be a scaling right triangle, or right scaling triangle. Our last theorem is our remote interior angle. So this angle on the outside is equal to these two angles added together. So we'd say that. All right, angle 1 is equal to angle 2 plus angle 3. So it's remote interior. So the angles that are the opposite interior angles. So we have one interior angle right here. It's not the one to that side, not adjacent, away from it. So let's go look at it. So we want to solve for angle 1. So remember, angle 1 is equal to its remote interior angles, or 40 plus 30. So it's say angle 1 is equal to 40 plus 30. 40 plus 30 is 70. And we go here. This angle right here is 113 is equal to 70 plus angle 2. So we'd say that 113 is equal to 70 plus angle 2. Subtract 70, you get 43. Last example, angle 3, for this one, angle 3 is equal to this plus this. So angle 3 is equal to 45 plus 45, which is 90. Okay, so that's our lesson for today, triangles. Just remember, they all add up to 180 degrees. That's our first one. Next one we have labeled. So we have equilateral, equiangular. We had isosceles and scalene. Then we had acute, right, and obtuse. And then our last one is the remote interior angles.